Hello and welcome. In this tutorial, we will create a CRT and VHS effect in Max. We will start with an almost empty Max patch. Here I have a jit.world as our rendering context because we're working with textures. Here I have a jit.p window so we can monitor what we're doing. And this is a simple input video. So this VHS or CRT effect is actually a collection of many different effects or effect stages. So I watched many YouTube tutorials on how to create this look in video editing software. And so some of what I'm going to show you is probably more a VHS artifact and some is probably more a CRT artifact. So for every stage, or for every effect stage, I will be using a different jit.gl.pix.codebox because first of all, it's just cleaner and the patch is not so cluttered then. Second, we will sample a texture at multiple stages, and within one jit.gl.pix object, you can sample a modified texture. So when we're doing something like this, just plugging this in here, creating a codebox object. When I'm saying the output is just sampling the input at normalized coordinates, this is not a problem, but let's say I want to modify this, just add 0.1 to it, then we're getting an error. So this is not allowed. That's why we'll be using different codebox objects. Okay, yeah, so this tutorial consists of 6 parts. The first one is a barrel distortion to simulate a curved screen. The second one is tape distortion to distort the image with vertically moving lines. The second one is a blur. So we're only going to blur one of the channels for this kind of VHS color smearing effect. In the fourth part, we will create a scanline to create this flickering image scanline effect. In the fifth part, we will add noise. So we will add a noise function from the book of shaders. And in the sixth part, I will add chromatic aberration. So this is this kind of RGB color displacement. So let's start with the first part, the barrel distortion. So this is simulating a distorted screen. So I'm creating the first codebox here, plugging it in here. How do we do this? First, we're going to create our distorted UVs. So let's maybe call them, I don't know, barrel UV. This is going to be signed normalized coordinates. And I will also put the output, set this to the output so we can see what's happening. So here we have signed normalized coordinates going from -1 to 1 on the x and on the y axis. Then we will multiply this by more or less a circle. So what do I mean by that? If we just take the length of this, we can see that we're getting a circle. And you can see that not much is changing here because I think it goes from 0 to the square root of 2. So if we're dividing this by the square root of 2, this fade looks much better. And then to apply this to our UVs, I will just say we will multiply this by the signed normalized coordinates. And then to get back into a range of 0 to 1 for our UVs, I will just say barrel UV equals barrel UV times 0.5. So this now goes in a range between minus 0.5 to 0.5, and then if we add 0.5, it will be in the range of 0 to 1. So now here we have it. And when we're sampling the input, we're saying, okay, input 1, we're sampling it using the barrel UV, and we're also using the bound mode clamp, so it's not wrapping around. So this looks way too extreme. So what I want to do is crossfade between our regular UV coordinates and the barrel UV coordinates. To do so, I will introduce a parameter. Let's call this barrel, I don't know, distortion amount. Let's set this to 0.25. And now to create the UV, I will just crossfade between them. So I will say mix is normalized coordinates and the barrel UVs, and then we will use this parameter to crossfade between them. Then I can use this variable down here. And now when we're using, now you can see we can control it from the outside. So first part done. This is the screen distortion. Then coming to the second part, the tape distortion. So I want to have vertically moving lines that then distort the image. So I guess this would be more of a VHS artifact. To do this, I will first use a jit.gl.pix.codebox object. So here we have various noise functions. I want to use the, what's it called, noise.cell. And so this is just the noise.cell, but I want just to have horizontal lines that are moving vertically. So I will say that the, where is it here? The scale is 0 for X and 3 for Y. So now we have these lines. And to get them to move, we can use the jit.time, which just outputs an increasing number. And then we can send a message offset and say, okay, 0 for the x-axis and whatever is coming here for the y-axis. And now we're moving. So to use this to distort what's coming in, I will use another codebox here. And let's say that the output is just sampling the input with normalized coordinates and an offset. So at the moment this does nothing because we have to create the offset, and the offset will be what is the offset? So we can, okay, before I continue here, patch this in here, and then I will use a trigger list. So the first input here is going to be the picture that is coming in, or the video input, and the second input is going to be the BFG distortion. So we can say offset is this distortion that's coming in here, but we only want it on the y-axis, so we multiply it with this vector, so 0 on the x-axis, 1 on the y-axis. And then we can sample it here, so we're taking the input plus our normalized coordinates plus this offset. Sorry, we're taking the input, we're sampling it at our normalized coordinates plus this offset we created. And then we have something like this. But I think this looks too extreme, so we can create another parameter and call this one distortion amount, set it to something like 0.1, and then we can multiply this by distortion amount. Yeah. And what would happen if we're using X and Y? Then you can see that it's also shifted in the X direction, which we don't want. Just tidying up a bit here. So this would be the second module. So for the third module, going to implement a blur, but we're blurring only one channel. So this gives this kind of color smearing effect. So how can we do this? First, I need this jit.fx blur, and let's say, okay, the amount is 1. So this is just blurring the whole image. But as I said, I don't want to blur the whole image. I just want to blur one channel. And I also noticed here that I want to set this to clamp so it doesn't wrap around. I'll maybe put it like this. Yeah, that's better. And now here for the blurring, I will do a similar thing. I will split this texture into 2. So here we have the regular texture coming out, and here we have the blurred one. And then I will create another code box here. And how can we do this? I think I will just blur the red channel for now. So we can say red equals the second input. So just what's coming in here. And the output will be a vector consisting of the red channel that is blurred, and then green and blue will just be from the unblurred version, so to say. So we can combine this. And get something like this, plus an error. What's the error? Is this an older one, or is this still relevant? No. Okay, it doesn't really make much of a difference. So maybe we can introduce a parameter, call this one blur amount. Let's set it to 1 for now. And then we can, oh, I'm running out of space. Then we can say, okay, we're mixing just input 1, so the red channel of input 1 and the red channel of input 2 using this blur amount. And again, we can access this from here. Okay. Now something is happening. I mean, we can also change the amount here. Yeah, it does make a difference. So I will leave it at, I don't know, 1.5 for now. Okay, coming to the next part, which would be the scan line, and I already ran out of space. What can we do about that? I will just put this here, put this over there, and then I can shift the whole thing here, and hopefully we have enough space on the right side now. Okay, where was I? Ah yeah, the scan line thing. Again, I will use a, where is it? I just created something and I can't find it. Okay. Second try. Okay. So I will use another code box here. So we can plug this in here. Plug this in here. Oh, and what also might be needed is sampling down the whole thing, because now we're at full HD. But let's say we're using a texture with the dimensions something like 640 and 360, and let's say a depth 0. Yeah, okay. So now that we downsampled, you can also see that the effect got stronger here. Okay, I am digressing. Where was I? Ah, yeah, the scan line. Okay, to create these scan lines, I will first we can use a sine function. So let's call this one lines, and then say output 1 equals lines. And then here we can say this is going to be the sine of, no, let's start simple. We can take the normalized coordinates and just extract the y coordinates. So we're going from 0 to 1 on the y-axis. If I plug this into a sine function, not much happens. But if I multiply this by, let's say, 15, you can see that this wraps over. So we will now get an output that ranges from 0 to, no, not from 0 to 1, but from -1 to 1 with this frequency. So if we change this to 25, we get more of those lines. But I also want to animate this, so we can create a parameter, call this one pause for position, and add it in here. And then we can use another jit.time to animate our position, so the lines will move. Oh yeah, look at that. But this is kind of slow. Let's make it a bit faster. Yeah, okay. But these lines are way too big. No, they're not too big, but the frequency is way too small. So we can create another parameter, call this one, I don't know, resolution, and set it to something big like 500. And then we can copy this one and put it in here. Oh yeah. I guess you can see, or I guess there will be a lot of aliasing looking at this through a YouTube video, but if you make this one yourself, you can see it in full effect. Okay, but we don't just want the lines, we also want to multiply this by our input. So now we have these lines, but they're pretty dark at the moment. So maybe we can do something like lines plus equals 1. Okay, now we have the lines and they're ranging from 0 to 2 at the moment. So, I mean, it's probably a good idea. How can I do this? Okay, I will say lines equals lines plus 0.5 plus 0.5. So now they should be in a range of 0 to 1. Ah, but it's still so dark. Okay, let's just keep it like that. I think this looks okay. Okay. Now this was the 4th module, scan lines. Coming to the 5th one. Here I will just add some noise. So again, using a codebox object. So the noise function, I'm going to steal this from the book of shaders. So I'm looking for this one, copying it, putting it in here. So this is GLSL shader code, so we have to adapt this, so we don't need this float in here. We don't need this in, we can just say ST. And for the rest, no, I will call this one UV, so it's clearer. And then we have UV. We also don't need this vec2, it's just vec. Okay, is this even working? So output 1 equals random of our normalized coordinates, which are the input. Yeah, okay, this is working. But as you can see, this is only in black and white. Okay, so what I would like to do is, instead of doing it like that, I will say I will create different different noises for different channels. So let's say red equals this one. Then I can copy this, put it here, put it here. The green channel is this noise, and the blue channel is this noise. But at the moment, this is just the same. So maybe we can do something like that and just change the number slightly. And then we can, as an output, so return a vector with R, G, and B that we just created. And now we have this colorful noise here. I'm not sure if this is needed. Yeah. It's okay like that. I want to fit everything on the screen. Okay, but I also want this to be animated, so we can say something like plus in 1. So now it's animated. And I don't just want the noise that's coming in, I want a combination of the noise and the input video. So what we can do is create a parameter, call it noise amount, let's set it to 0.1. And then again, we can use the mix operator to crossfade. So we will take so if this, where is it, noise amount. If this noise amount is 0, we will just take the input as it is. And if it is 1, we will take just the noise and everything in between that. So I again can create it out here, and then you can see I can change the noise. I will leave it at 0.1 for now. I'm not sure if this will translate well on YouTube, but yeah, I guess you have to try it out for yourself. Okay. Okay, coming to the last module or the last part, which is the Chromatic Aberration, which is just like an RGB color displacement. So we will displace different channels at different amounts. So for last time in this video, creating a codebox object, plugging it in here. Then how can I do this? I would just create a parameter called this Chromatic Aberration amount, set it to a very small number, 0.01. And this will just be the amount that the UV coordinates will be displaced. So what do I mean by that? This time I'm going to use the green channel. So green channel equals sampling the input. So input 1 at our normalized coordinates plus this offset that we just created. Again, I will use bound mode clamp. Oh no, not like that. We can put this down here. So we can use just the unaltered red channel from the input, then this displaced green channel, and then again the original blue channel. And now nothing. What did I do wrong? Okay, we have input 1 red channel, 1 blue channel. This seems to be okay. We're sampling input 1, normalized coordinates, plus this one. Is this the right one? Okay. Is this the problem? And can I just say input 1 point green? Okay, this one seems to be the problem, this line. We're sampling input 1 at normalized coordinates, bound mode clamp. Oh. Equals bound mode clamp. That was the problem. Now it should be working. Yeah. Oh, and I think we should only take the green channel here. Yeah. Now for the last time in this video, we can access this from outside. And see what it looks like. Yeah. Maybe something like that. Yeah. And so this is maybe looking a bit extreme, but you can play with the values. Changing, where is it? The distortion amount, maybe here. Or you can also go to the extreme and create really glitchy, gross looking stuff. I think that's it for this video. I hope you found this useful, and thanks for watching.